Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. How are you, everyone? I hope you are doing well. This session will not be online because of many reasons. Okay, so it will be recorded, inshallah Rabbil Alameen. Some of you may ask, Mr. How can we be recorded as present or absent? Okay, what about the attendance? Okay, the attendance, inshallah Rabbil Alameen, will be recorded depending on a quiz that I'll send after this recorded video, and this is in any recorded video. Okay, in any recorded video, I'll send a quiz after the video, and when you solve this quiz, you show that you attended, you watched the video, and you understood it. Okay, so the students who will solve this quiz will record it as present, and so on. Well, let's go. This is the first section in the new chapter, which is chapter 13. Okay, this chapter 14 is talking about the refraction. To understand the refraction, and we talked about refraction many times, okay, but to understand the refraction, let's look at some phenomena where the objects appear to be in different positions when we look at them from another medium. For example, when our eyes in air and we look at a position which is, and look at an object which is in water or beneath glass or something like that, we feel or we see it in a position that's different from its real position. Okay, if we ask ourselves what is the main reason of all these phenomena, okay, the answer will be the refraction. So when we look at this spoon, we feel as if it's broken. Allah, Allah. We feel as if it's broken in water. Why? Because of refraction. When this fisherman looks at the fish, okay, he looks it in an appearance position, okay, which is higher than its real position. All these and other phenomena of the most relate, sorry, refraction, not diffraction. Okay. Well, what is refraction? So the refraction is the bending of light as it travels from one medium to another medium. This is the idea. The transfer of the light between two mediums, okay, gives the refraction. Why? Because the first medium has a speed of light and the second medium has another speed of light. Okay, so this change in speed of light makes the light ray bend, makes the light ray bends. For example, if the light ray is going, this is the surface of water, for example. So here we have water, and here we have air, for example. These are two different mediums. Okay, if the light is going from water to air, it will not go straight. No, it will bend like this. It will bend like this. So what is the reason of this? We know that the speed of light in air, which has the symbol c, approximately, and it approximately equals c, which is the speed of light in the vacuum, which is approximately 3 times 10 to the power of 8 meters per second. Okay, and the speed of water is less. Let's give it the symbol v. Okay, they are different from each other. The speed of light in air is more than the speed of light is of the speed of light in water. So we have two different speeds of light. So the ray bent. Okay. So if I ask you what is the reason of refraction, it's the change in it's the change in it's the change in light speed when it transfers between two different mediums. Okay, well, so as light ray travels from one medium to another medium where its speed is different, the light ray will change its direction, except for in one case. You have to focus this point. There is only one case where the light will not bend. What is this case? This case is if the light, this is air, okay? If the light falls along the normal, what does it mean along the normal? The light falls normal to the surface. It will not bend. It will go straight. It will go straight. This is the only case where no bending happens. Well, now, because we mentioned the speed of light, let's talk about the factors those are affecting the speed of light. The speed of light, we have to differentiate the speed of light into two main categories. The first one in vacuum. In vacuum. The speed of light in vacuum, it has the symbol c. Speed of light called c. So c is the speed of light. C equal, why c? Because it's constant. It's constant for all kinds of light, for all wavelengths, for all frequencies. Anything can be called light or electromagnetic wave have the same speed in vacuum, regardless its wavelength. If it's red, if it's blue, if it's green, if it's ultraviolet, if it's X-rays, no difference in wavelength. So C equal 3 times 10 to the power of 8 meters per second. And this value is the same, approximately the same for air. In our portion, we will use this value for air also in our syllabus. Okay, so in vacuum, regardless the wavelength. So in vacuum, wavelength, it doesn't depend on wavelength nor frequency. All the same. Remember that well. Well, what about in the second case, which is in mediums? We said that mediums, rather than vacuum nor air. Okay, in mediums, it depends on we will first of all, let's remember that we will give the speed of light the symbol v, not c. So remember that c, speed of light in vacuum, v, speed of light in medium, vacuum and air together. Okay, so v is the speed of light in medium. It depends on two things. Concentrate well. Number one, the kind of the medium. Number two, the temperature of the medium. Number three, the wavelength of the light itself. Concentrate well. So in vacuum, nothing affects wave speed or light speed. But in mediums, we have three factors. Number one, the kind of the medium. For example, the speed of light in glass is different from the speed of light in water. The speed of light in air is different from the speed of light in glass, and so on. This is the effect of kind of medium. Okay. What about the effect of the temperature? The effect of the temperature, if we have two pieces of glass, they are the same kind of glass. Okay, one is hot and the other is cold, so the temperature is different, the speed of light will be different. Okay, in air, if the air is hot and the air is cold, here the speed of light will be different. Here, in this case, the speed of light will be different. Okay, if we look at the light itself, you will find the third factor. In the same medium, if we have the same medium, for example, the glass, if the incident ray is red, the speed of light of red in glass will be different from the speed of light of blue in glass. Why? Because they have different wavelength. But if I ask you, what about the speed of light in blue and the speed of light, of blue light, the speed of blue light and the speed of red light in air or vacuum, you will say there is no difference in the speed. They have the same speed. Okay. Well, I hope it's clear. Well, now, inshallah, we will study a very important point that's related to the refraction, which is called the index of refraction. What is the index of refraction? Index of refraction, it measures the ability of the medium to bend the light. Okay, it measures the ability of medium to bend the light, and you can add this in your notes. Okay, the ratio of speed of light in a vacuum, the index of refraction, it's the ratio of the speed of light in a vacuum to the speed of light in a given transparent medium, to the medium we are talking about. Okay, so the index of refraction is the ratio, this ratio. Okay, n, it has the symbol n. It has the symbol n. Okay, n is the speed of light in vacuum, which is c, divided by the speed of light in medium. Okay, well, we know that the speed of light in vacuum is the maximum known speed. Okay, well, v is in the medium, it's always less than the speed of light in vacuum. Okay, this value is called the index of refraction. Now let's clear all drawings, okay, and record some notes. So here we call this n, okay, and we said that n equal c divided by v. C is the speed of light in vacuum or air. Speed of light in vacuum or air in our book. Okay. V is the speed of light in the medium that we are talking about. For example, if I ask you what is the speed of light in air, it will be approximately 3 times 10 to the power of 8 meters per second. If I tell you that the speed of light in water is, let's see, or any other medium, not water, any other medium, it's 2 times 10 to the power of 8 meter per second. So n equals what? N of this medium will be 1.5, 1.5, nothing else, 1.5. Okay, so this is the refractive index. So the refractive index, it measures what? Remember, it measures the ability of the medium to bend the light. Okay, so if I want to find the refractive index of a medium, what will I do? I'll find the speed of light in this medium, and I'll divide the speed of light in vacuum over the speed of light in this medium. This will give me n, which is the refractive index of this medium. It's important to understand it. Well, what is the SI unit? It's unitless. Why is it unitless? Because meter per second will be cancelled with meter per second. So it's unitless. And it's dimensionless. It doesn't have dimensions because it doesn't have units. Okay. Well, we said n of any medium equals c divided by v of light in this medium. Well, c is always more than v. So n is more than 1. Why? Because c is the maximum known speed. C is the maximum known speed. Okay, so c, which is the numerator, is larger than the v, which is the denominator. Okay, so c is more than v, so n will be more than 1 because the numerator is more than the denominator, so n will be more than 1. I hope it's clear. Well, this table represents some values. You don't have to memorize this, or but that shows some points like this. When we talk about, this is the indices, it's a plural index of refraction for various substances. Look at air. You will find the air is approximately 1. Okay, I'm interested in air. Okay, why? because let's remember, N of air will be C divided by what? Divided by V in air. What is C? C is the speed of light in vacuum. And we said that the speed of light in vacuum is approximately equal to the speed of light in air. Okay, so it will be, so this is V approximately equal V in air. So V in air and V in air, they will cancel out. So the N of air will be 1. Which unit? No units, remember that. Okay, so in the air,